Hey guys, welcome back to chapter 1 in general chemistry. Today we are going to talk about something called dimensional analysis. Dimensional analysis is something that we will be doing pretty much every day in chemistry from here to the end of the semester. I'm going to go through this painstakingly slow because I want to make sure that we set a nice, firm, solid foundation so that when we get to more difficult problems that have to do with moles and Avogadro's number, that we have a good foundation, a good set of skills to rely on. So, dimensional analysis. Dimensional analysis, eventually, we are going to answer the following question. How many kilometers are in 456 miles? So with dimensional analysis, what we're doing is we're essentially changing the units from miles to kilometers. That's all we're doing is we're changing the units. In order to change the units, we need a couple pieces of information. First, we're going to need something called an equality. An equality shows the relationship between two units that measure the same quantity. So here we see an equality. 1 kilometer equals 0.621 miles. So what this means is they are measuring the exact same distance. So if I ask a student to stand right next to me, take this tape measure and run till it says 1 kilometer. Student takes off running and stops, 1 kilometer. And then I ask another student to stand next to me, grab a tape measure and run until it says 0.621 miles. That student does it and stops. Those two students are going to be standing right next to each other. 1 kilometer is the exact same distance as 0.621 miles. So we're going to use this fact that these two are measuring the same quantity, and we're going to be able to use that to change units, to go from one unit to another. The application of the equality is going to be what we call the conversion factor. So I may say something like, what conversion factor do we use? How do we write our conversion factor? So writing the equality in the form of a fraction is how we are going to move from one unit to the other. We see that from the equality that we discussed, there's going to be two conversion factors. So I put kilometers on top, miles on the bottom, or I can put miles on the top, kilometers on the bottom. Which one do we use? It depends on our problem. Okay. So first piece to get out of the way, just a little terminology. Equalities are going to be the relationship between the two units that we need to find. And then conversion factors are the application of that equality, writing it like a fraction. All right, so now we're ready to solve our problem. Dimensional analysis. This gives us the name because we are using the units to guide our problem. Okay, so the very first thing that we are always going to do for every dimensional analysis problem that we ever come in contact this semester is we are going to write down the information that's given. Write down the measurement that was taken. So in this case, we started with 456 miles. So that's going to be the very first thing that I write down. I teach the train track method. So the train track method is going to look something like this. We write down that information, and then we're going to draw a straight line and then a vertical line. This is essentially making it look like a train track. So here's what a train track looks like. The train chug-a-lugs down the train track. So that's how it gets the train track method. Okay. So we write down information that's given. We draw our lines. And now we're ready to start solving. The first thing that's going to go in my train track is going to be the unit that I'm trying to get rid of. So I'm in the unit of miles, and I want to cancel out the unit of miles. So that unit is going to go on the bottom of the next track, or it's going to go diagonal from the original value. The reason is we are going to divide by that unit. So I have miles on top, miles on the bottom, and those units will cancel out. We're trying to get rid of them, right? The unit that goes on the top is going to be our destination. What is the question asking for? In this case, it's asking for kilometers, so that's going to be the unit that goes on the top. So we cancel out the unit on the bottom. We keep the unit on the top. That's our destination. Dimensional analysis, letting the units guide the problem. So now we have our units into the train track. Now we just need to input our numbers. Inputting numbers is the last thing that we do. So to input the numbers, we go back to our equality, right? So what number was attached to the unit kilometer? The number 1 was attached to kilometer, so that is going to stay with the unit kilometer. What number was attached to the unit of miles? The 0.621 was attached to miles, so that is going to stay with the unit miles, 0.621. Okay. Now we're ready to solve. To solve this, we're going to multiply across the top, divide by whatever's on the bottom. So I plug in to my calculator 456 times 1 divided by 0.621, and my calculator spits out something like this. Right? Lots and lots of decimal places. But what do I need to consider? What do I need to think about? Yeah, sig figs. Sig figs. We are always going to go to this first box to determine significant figures, right? Remember, this piece is a definition. It's an equality. So this would have unlimited significant figures. We are not going to be limited by the conversion factor step. That is not where we look for sig figs. We are going to look at the original measurement that was taken. So the original measurement has 3 significant figures. So when I report my answer, I can only report 3 significant figures. So 734 kilometers. Okay. For some reason, my pen stopped writing. But put a km after that. That is your introduction to dimensional analysis. This is a skill that you are going to utilize through the entire course of your entire semester of your general chemistry. It's a skill that you just need to know and have. So let's start now getting proficient at it when we're dealing with things like miles and kilometers, so that when we get to things like grams and moles and stoichiometry, that we have a solid foundation. I hope you guys found this helpful.